We have examined the current controlled voltage source and found out the conditions under which it does behave like a current controlled voltage source with a trans resistance or a trans impedance of Rm. Other important aspects of a control source are the input and output resistances. We will evaluate them now. The input resistance, of course, is the resistance looking into this part, that is between the two terminals across which the input source is connected. It is influenced by RL, and similarly the output resistance is the resistance looking that way between these two terminals, this point and ground, across which the load resistance is connected. Okay. As usual, you can evaluate them by connecting a voltage source and finding the resulting current, or connecting a current source and finding the resultant voltage. Okay. Now, to calculate the input resistance, I connect a voltage source V test between this point and ground. I evaluate the current I test that goes in there. The ratio V test by I test will give me the resistance looking into it. Okay. Now, VGS equals V test here, right? So this current source here is GM V test, and this voltage is of course something we don't know. Let me call that V0. The current here is V0 by RL, and this I test simply comes that way. The current I test is whatever current is going through Rm. Okay. So this voltage here is I test times Rm. So this voltage V0 is nothing but VGS or V test minus I test times Rm. Okay. V0 equals V test minus I test times Rm, and writing Kirchhoff's law here, we get I test equals GM V test plus V0 by RL. Okay. So substituting for V0 from there, we get an expression relating V test and I test, and it turns out that the input resistance, which is V test by I test, equals RL plus Rm divided by GMRL plus 1. Okay. So this is the resistance looking into the input. Now what happens here? Ideally we would like the input resistance of a voltage controlled current source to be 0. Okay. That's because if Rin is 0, regardless of the value of Rs, all of this II will flow into the circuit. Okay. So this current here will be equal to II if Rin is 0. So that's why we want 0 input resistance in a current controlled voltage source. Ideally, of course, we won't get 0, but we get a small number, and here you can see that this number tends to 0 if GM tends to infinity. Okay. So the key to realizing an ideal current controlled voltage source is making GM infinity. Okay, this again you have seen repeatedly for all control sources. If GM tends to infinity, the control source becomes ideal. That is, it follows the relationship that is required, and also its output and input resistances will be exactly as we want them. Okay. Again, we want the product GMRL to be very large if this has to behave like a good current controlled voltage source. Okay. For calculating the output resistance, the input current source is set to 0, so that means that it becomes an open circuit, and I connect a test voltage source between these 2 points, okay, and find the current that flows. Okay. You can see that the current that flows here equals this voltage divided by the total resistance. Okay, so this current will be V test by Rm plus Rs. This VGS will be V test times the divider ratio Rs by Rm plus Rs. So this current will be GM times this number. Okay. So now you can work out that R out, which will be V test by I test in this case. Okay, you can find I test by summing this current and that current, and that will be equal to Rs plus Rm by GM Rs plus 1. As before, as GM tends to infinity, this output resistance becomes 0. Okay, it's a current controlled voltage source, so the output resistance should ideally be 0, and it will be 0 if GM becomes infinite. Okay, so we want this GMRS product to be very large so that this resistance becomes quite small. Okay, you can also observe the symmetry between this expression and what we got for the input resistance. Okay, they are quite similar. We have Rs, wherever we have Rs in this case, we have RL in the other case. Okay. So our current control voltage source does give you a small input resistance and a small output resistance as desired, provided that the value of GM is very large. Okay.